again, as we talked about with these, there's a lot of different ways to work the various questions. So the first one, how many times must the tire rotate to cover the distance? This is actually, the questions weren't necessarily in any kind of order. Like you do this, and then that'll lead to this, that'll lead to this. Some of the calculations you did, some early ones, kind of pretty much could be used in a later one or so forth. So, or you may have found one of the, answer number 5 might have been one of the first things you found, didn't even know it was hidden in here, whatever. So, a lot of it depended on rounding. We talked about rounding. We talked about if you round too much, and in a calculation and then use that can throw you off. And so I didn't want to penalize too harshly, but then again, like we talked about, do it, like in the directions talked about, that show your work so that it validates your answer. Some of you, I think, punched a lot of things in the calculator, but didn't write very much down, right? And that wasn't what the directions were on that. And so you might have lost a point or so there just from that standpoint. But how you arrived at it didn't really matter to me. There were a lot of different ways to think about it. Like right here, I did 2 different ways of thinking about that first answer. If you had, I don't remember what the number was, 3760 something for that one, that probably came from rounding when you do, I think that was 27 pi. I think that was, I think where you probably got that, I think if you took 27 pi divided by 12 divided by 5,280, if you had this flipped around, maybe there's a number goes out like 0.00133 something. So maybe that's what you did, but somewhere along the line you rounded something and then used that as a calculation, and that threw you off, and that was, that was fairly significant. It was like 150 rotations off because of rounding. Okay. Now on a 4.9 mile bike ride, maybe that number of rotations isn't huge, but it is fairly significant. So what I did is, if you use that then down at the bottom, which many of you did on the very last answer, right? Because basically the last answer is just half of that one, right? How many pedals did you make, right? Because every time you turn the pedal, and that's actually the question, the second one, what effect does riding in 4th gear have on the ride? Now it's pretty lenient on your answers there. What effect does riding in 4th gear? Some people say, well, that's easier to pedal, well, I guess, compared to maybe 5th gear. But I mean, what it was, the effect of 4th gear was, what I was referring to there was the radius of the sprockets. In other words, every time you pedal, the tire is going to go around twice. Every time you pedal, the tire is going to go around twice. So if it's this many, if the tire goes around this many times on the trip, then you're going to pedal half as many times. So the very last question, how many times you pedal, is just divided by 2. So obviously if you had this wrong and then you use that, you're going to get the last one. So I only took off a -1. I probably put it down at the bottom one, or maybe I put it on the top one, whatever. But that's, okay, so that was like 4 points I just took away from because of the round. Okay, that was the end. Okay, what would happen if I rode with a smaller back sprocket, a higher gear? What I was looking for there, again, some people had some different things. And there was one that I think I might have taken 1 point off on, because a number of people said, well, you'll go faster. Well, no, that's not the effect of getting in a higher gear. I mean, you can go faster if you get in a higher gear. You have to pedal harder, but then that changes how you pedal. Like, for example, if it says, so that's not really what the question was. The question was if it's, you'd have fewer pedals, all right? You'd have fewer pedals. So if you go to a smaller back sprocket, you would have fewer pedals to get the same number of tire rotations, okay? So, but yeah, could you pedal faster? Yeah, I suppose, or if you pedal harder. So if you did a good job of explaining it, it really came down to if you did a good job of communicating, explaining yourself what you meant there, okay? So again, later, I'll let you keep them, but if we, if you want to talk to me during work time or something about your answers, I'd be glad to. And then the other one, a lower gear, would be the reverse of that. So a lower gear, you're going to go more times around to get the same number of tire rotations, right? Same number. So if you rode a smaller gear where one pedal only made the tire go around once, right? You still need this many tire rotations to cover the distance, right? No matter what gear you're in, you need this many tire rotations to cover the distance, right? Because this doesn't have anything to do with what gear you're in. This is just the circumference of the tire and then changing that into inches into miles, okay? And so you're going to need that many rotations, smaller gear. So if one pedal rotation only made the tire go around once, you're going to need twice as many pedals to get to the arch length, right? All right, if you went one rotation per second, how long would it take? Okay, so that's that question. So how long would it take? Now, why did I set it up this way? Again, what I'm thinking of is, what was it in hours first? What did it say? How long would it take? Oh, it didn't really say. So I'm thinking, well, I want to end up with hours. I want to end up with hours. So that's why I put time on the top. Okay? I want to end up with hours, so I put time on the top. And what I knew is 1 second was going to be one pedal rotation. Now, how many times did the tire go around in one pedal rotation? Twice. 27 pi was the circumference of the circle. So if a tire goes around twice, it's going to be 54 pi. Right? Now, your work might not have been the same as this, but I knew I wanted to end up with hours, so I did 1 second is one pedal rotation. That's going to be that many inches. And then I just went about canceling out seconds to get to hours. And then what did I still have? I still had inches, so now I needed inches to get into miles. So I had inches to feet, and then feet to miles, and it was 4.9 miles was the last thing I had to do for the whole trip. So everything cancels out but the hours. And so that was 0.508 or 30.5 minutes, okay? What's the speed in feet per second? So I could just take the answer that I just got and say, well, that's 4.9 miles in that many hours, so that's miles per hour. So there it is. So I actually jumped to the next one, didn't I? Miles per hour. So I could just do that. Or if you wanted to do the feet per second first, take your miles per hour and then convert it into feet per second just by canceling out those units. Again, not the only way you could come up with those numbers, but those are just examples of what you could have done. Okay, if I go 38 and a half hours, I did the same thing here. I wanted to end up with revolutions. I want to know how many times am I going to pedal. How many times am I going to pedal? So I want to end up with revolutions. Well, I know I'm going one revolution in 1 second. So there's 60 seconds in a minute, 60 minutes in an hour, and I'm going to go for 38.5 hours. And so that's going to cancel out everything but revolutions. So I get 138,600. Okay? And again, there were some people did some different things there to get those. All right, and then the last one was just probably the easiest way is just take your answer from up above. If the tire goes that many times, it's going to be half as many pedals. Or you could work it out this way. Again, I want to end up with revolution. So the same thing I did on the previous problem, I want to end up with revolution. So I start there. One revolution is this much. It's twice around the tire, which is that. Okay? And then get the inches to cancel into miles, and I'm going to go 4.9 miles. And so everything cancels out but the revolutions. So it comes out 1830. Okay, the only way it comes out 1880, was it 1880 something you had? Is if somewhere you used a rounded number and then went. That's one of the things I like about this, is nothing's ever rounded. You just do it all kind of at once, and you don't get into the rounding there. Okay? All right, so a lot of different things going on there. I'll get those put in the grade book here later today, hopefully. All right, so you can keep those. Or get rid of them. All right, homework questions. We're going to talk a lot today about the quiz on Monday. What's expected. We probably will do a little bit of review right before and as well. But I'll kind of really emphasize the things we do today that I expect you to do in the quiz, and then we'll be doing some other things that may not. They're still important, and they're important as we go ahead, but they're not going to get. All right, anything here you want to look at?
Like on 76, I think I figured it out, but how do you type that in on a calculator?
Yeah, let's talk about the calculator a little bit. There are definitely going to be some, and so I don't know if you want to, in your notes or something, make it, I'm going to write it out a little bit, kind of what's on there, but as far as some example problems, you want to put stars by them or something for the quiz. There is going to be a section on the quiz where you are going to type these into your calculator. So secant of 225, a couple ways to do it. Okay, first of all, secant is 1 divided by cosine of 225, right? So that, and we have to turn things into sine, cosine, and tangent. So if you get secant, cosecant, and cotangent, it's the reciprocal thing. So one way would be to just do that right there. So let's try it. So 1 divided by cosine 225. Now, depending on your calculator, some people have to type the 225, and the old style calculators, you used to have to type the 225 and then hit the cosine. Does anybody have a calculator like that? Okay, you can just hit cosine and then 225. Okay. So 1 divided by cosine 225, hit equals. That's one way. The other way to do it is to hit cosine 225, and then what's the key? Is it x negative 1? Is that your reciprocal key? Some calculators might have a 1 over x key. So you can hit cosine 225. I think you have to hit equals. I think you have to hit equals and then the reciprocal key. Okay? I think if you don't, then you're going to reciprocal 225. I think is what's going to happen.
If you close parentheses.
Or if you close parentheses. So if you do cosine 225, close parentheses, and then do the reciprocal, you're okay? Okay. All right. So you got to be a little bit careful there. So you can either rewrite it first, and then just do 1 divided by cosine 225, get equals, or you can do cosine 225, and then the reciprocal. Okay? And then make sure you're in the right mode. Always, if it's degrees, there will be a little degree symbol. Okay? If there's not a degree symbol on the number inside here, then it's radians. It's radians. Now, if there's a pi on it, that's a dead giveaway. I can't think of a time we would ever put pi and then a degree symbol. I mean, I guess we could. You could have you could have pi degrees. I mean, you could. It's just a number, 3.14 degrees, right? I mean, you could, but that would be purposely confusing, and even I wouldn't do that. So I can't think of a time I've ever seen it. Okay. But remember, we talked about this on that one quiz. Pi is not a unit, right? Just because pi's there, it's typically radians, right? I mean, that's the way we often do radians, but pi is just a number. So the key is the degree symbol there or is it not? All right, what else? Yes.
11.
Yeah. Okay, so we're given, and this is definitely, put a star by this. This homework assignment really had a lot of what the quiz would be about, to be honest. Okay. 11, so you're given, now what I might give you is not even the graph, I might give you this problem just as this, right? Just angle theta has the point given on its terminal side. That would be the direction. The angle theta has the point given on its terminal side. List the 6 trig functions for angle theta, right? And so what you want to do is just plot that point. So negative root 3, that's about 1.7, and negative 1, so that would be this point here. But the key then is what they're wanting you to do is draw a triangle, right? So we got this thing here, right? You got this picture. But what they want is a triangle. So if the x is negative root 3, that means that is that. And if the y is negative 1, that's what they want you to do, right? So when they're giving you this coordinate, it's like telling you the 2 sides of the triangle, the x and the y. Okay? And that's why we know it's in the third quadrant. Negative x and negative y. And here's your theta. And remember, the triangle is always drawn here to the x-axis. So we need Pythagorean theorem to get this. And what is that? 2. Right? So it's not a unit circle thing, right? Unit circle, the radius would be 1. This would be 1, right? But it's not. So now we just write the 6 trig functions. So sine theta would be opposite over hypotenuse. Now, isn't that interesting? That is one of our special angles, or special values. Is what angle is theta right now? We can tell just from that. What angle is theta right now? Isn't that a 30 degree? Isn't that a 30 degree? Think about your unit circle here. The sine is the y. When the y is 1/2, that's at 30 degrees. Okay, this kind of gets into the idea of reference angles. Not necessary for this problem. Didn't even have to think about that for this problem. Didn't matter. Okay, it just happens to be a coincidence that that relationship is the 30-degree scenario. Okay, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, I want you for sure to cancel those negatives. I'm going to be okay if you leave it like that, but if you want to go to root 3 over 3, that's okay too. Okay, and then the other three the reciprocal ones. Okay? So that was that section. Definitely going to be that on the quiz, right? Going to be ones where I give you a terminal side, a point on the terminal side, draw a triangle, do the trig function. Okay, what else? There was some reference angle. Was there some reference angle ones? Okay, we're going to do that some more today. So we're going to practice that some more. We're going to do some partner stuff.
Why was the secant on 39 undefined?
Secant of 3 pi halves. So if I'm doing secant of 3 pi halves. Okay, so as soon as I see 3 pi halves, right? I mean, for you guys, when you see 3 pi halves, what do you think? 270 degrees, right? Down around. Is there a triangle to be drawn? You cannot draw a triangle for that, right? I mean, if you're trying to draw 3 pi halves, that's there. There's no, if there's a point on there, there's no triangle. You can't draw a triangle. Okay, that's where what we call the unit axis comes in. Okay, so that's where yesterday I gave you that. So if you ever get, these were called the quadrant angles. The quadrant angles. Okay, matter of fact, one of our little warm-up or one of our little review things, a quick quiz, I don't know, Mrs. Payne called it a quick quiz, so I'm gonna show it to you, but it's not a quiz, I'm not gonna grade it, but she calls it the unit axis. The unit axis, I usually say unit circle, but I typically when I do this, I go ahead I usually go ahead and draw in a circle, okay, and then just think of these points. So this is where the unit circle is for sure the thing you want to do anytime you get a 90, a 180, a 270, a 5, anytime you get those. You want to go to the unit circle because you can't do triangles. 30, 45, 60, those, we can do unit circle, we can do triangles. We can do either one. They give us the same thing. Unit 90, 180, the only way really to get them, until we learn about graphs, the only way to really get them is unit circle. So secant is the reciprocal of cosine. Right? So what is cosine? Cosine is x, right? Because we can just do that, right? Just x. So the cosine is 0. So what's 1 divided by 0? Undefined. That's why it's undefined. Okay? Now, you could think of secant as just 1 over x then, right? You could think of secant as just 1 over x. Okay? But it's a reciprocal of cosine, and cosine is the x here. So anytime we go to the unit axis, right, cosine's the x, sine is the y. All right, we're going to practice some of those today, too. All right, good question. All right, let's talk about these problems. Just add these right to the bottom of your homework somewhere. These are not going to be on the quiz. Okay, these are not going to be on the quiz, but the next thing we do after the quiz will involve this. Okay, and these are the problems I was thinking of yesterday when I was talking about. Somebody asked about it. It was very much like what we had yesterday, but the difference was, I don't know if you remember, it was on yesterday's homework. It didn't say 0 to 360. What did it say? It said 0 to 90. So we were sticking in the first quadrant, so I was getting a little ahead of myself, and I was thinking about these problems. And that's where I was saying there's going to be two answers, right? There's going to be 2 degree answers and 2 radian answers that match up with those. So let's, sure I wrote that twice. Okay, so 1 in degrees, 1 in, and sometimes I forget to put the degree symbol on here, but, okay. Now, so not going to be on Monday's quiz, but we want to start the process of doing this. So basically we're solving this equation. We're trying to figure out what theta is, okay? So so the ones I want to focus on now would be ones with triangles, with the unit circle, ones we could do without a calculator, okay? Ones we would do without a calculator. So where does sine equal 1/2? At 30 degrees, right? Remember that? Good. Remember that's the one I always memorize. Sine of pi 6 is 1/2. Sine of pi 6 is 1/2. Sine of 30 degrees is 1/2. Okay, so where does sine equal 1/2? But if you go to the unit circle now, let's go to the unit circle and then we'll do triangle. If you go to the unit circle, where is the y 1/2? Well, you're right there, 30 degrees. Where else? Straight across over here, isn't it? Which is 1/50 or 5 pi 6, right? The y is 1/2 in 2 different places because you can go this way and up 1/2 or you can go this way and up 1/2. So sine, and that's when we talked about the quadrants yesterday, sine is positive in quadrants 1 and 2. So that would be 30 degrees or 150 degrees. Now here's how you can do it with a triangle. If the unit circle is not your friend and you're having trouble, remember note, you could do this with a triangle. You could say, okay, what kind of triangle would have the y be 1/2? Well, that would be a 30, right? It'd be this. But then you say, but wait a minute, I could have a triangle over here where the y would be 1/2. Now this would be negative root 3 over 2 here. But I could have 2 different triangles where the y would be 1/2. Reference angle 30, reference angle 30, right? So that's where this idea of reference angle comes in handy. In the first quadrant, sure, it's 30. But it also could be in another quadrant, and that's true with all the trig functions. When you go from 0 to 2 pi, all the trig functions have 2 different places that they could be equal to 1/2 or whatever these are. There's always 2 answers. Okay, so you just have to figure out that, and one of them is usually in the first or second, or, well, not if it's negative, but you usually find one, but you'll use your reference angles to find the other. So 30 here and 30 here. So that's 30 and 150. So then it's just a matter of writing down, okay, theta equals 30 degrees, 150 degrees, or theta is pi 6 and 5 pi 6. Okay, so we'll be going into that more later on. This will not be on the next quiz. Let me show you how to do it on the calculator. Okay, so here's how you would solve this on the calculator. Some of you have asked about that sine -1 above the sine key. That does not mean reciprocal. Okay, it does not mean reciprocal. Okay, it means inverse sine. And I think I've talked to you, didn't I talk to you guys about inverse? One of my pet peeves, there's a lot of different inverses. Did we have this conversation the first day or something? Yeah, about multiplicative inverse. There's reciprocals or a multiplication inverse. Opposites or additive inverses. And now what we're talking about here is a function inverse. So it's not reciprocal. Anyway, here's what you type on your calculator. So everybody in your calculator, type in a 0.5. And what we want to do to undo that sign, to get the theta by itself, it's not divide by sign. That's not what we're doing. We're doing the inverse sign. So hit second and the sign button. Now you might have done this in geometry with triangle problems. Maybe you've done this before. I don't know. I haven't taught geometry for a long time. Hit equals. What do you do? Now what mode are you in right now? Are you in degree? It depends what degree. What mode you're in. So if you're in degree mode, so hit 0.5, hit second sign, you get 30. See, it doesn't give you the 150, does it? It only gives you one answer. Because on your calculator, it's treating it as a function. One input in, only one answer out, right? So, even with the calculator, you're going to have to know about reference angles and quadrants, aren't you? So the calculator gave you the 30, so that's one of your answers. But then you got to know, okay, but sine is also positive over in the second quadrant because sine is the y. So draw a 30-degree reference over there. All right. So I'm going to want you to be able to do this with and without the calculator. The key will be if you see a special, one of our special values, root 3 over 2, square root of 2 over 2, then that's a no calculator. That's when I would give you the no calculator. Okay, so let's think about this without a calculator. Oh, wait, I was going to do this. Change your calculator to radian mode. Change it to radian mode. Now type in 0.5 and hit inverse sine, second sine. What do you get? 0.52 something. Why do you suppose you're getting 0.52? What's pi divided by 6? Take the pi divided by pi divided by 6 is like 3 divided by 6. Do it. Do pi button divided by 6. Do pi button divided by 6. You get the same thing, right? 0.52, right? So if you're in degree mode and you do inverse sine, you get 30 degrees. If you're in radian mode and you do inverse sine, you get pi 6. But as a decimal. Okay, as a decimal. All right. So probably want to be in degree mode for those right now. All right, negative root 2 over 2. What angle does that make you think of right away? 45 degrees. Except can it be in quadrant 1? Cosine is the x, and it's negative. What quadrant is x negative? 2 and 3. So what we're going to have is a 45-degree reference in these two quadrants. Because the x is negative. So negative root 2 over 2. But then this will be positive root 2 over 2. And this one would be negative root 2 over 2. And of course this would be 1 and 1. So whenever we have our special triangles, we think of these relationships. So the x here is negative root 2 over 2. So what two angles are those? This would be 135. And this one would be 225. Okay? And then in radian, this would be 1 pi fourth, 2 pi fourth, that'd be 3 pi fourths, 4 pi fourths, 5 pi fourths. Would be the two answers. Okay? And then when you get really kind of a really strange one, whenever it's cosecant, then it's not going to look like one of our normal ones, so we might not recognize right away that this is one of our normal ones, but it is, because what would sine theta be? This is cosecant, its partner is sine. What's the reciprocal of this? Well, it'd be this over this. Well, that doesn't look very good, so how about I do this to it? How about I do that to it? What do I get? 3 root 3 over 6. Oh, there you go. It's root 3 over 2. It is one of our special ones. You wouldn't have noticed it, but if I had given you this and said it was no calculator, you would know it has to be, because that's the only way I'm going to give you one of these, if it's one of our special angles, okay? So where is sine root 3 over 2? Well, again, it's positive, so where is sine positive? In 1 and 2. So, and we want the sine is the y, so that would be here and here, right? Root 3 over 2. What angle is that that's across from root 3 over 2? That's the 60, right? This would be 1/2. This would be negative 1/2. This would be the 1. So across, so this is where the triangles can come in handy, right? And this is this idea of reference angle. Okay? So this would be a 60 over here. So where does sine equal root 3 over 2? That would be at 60 degrees and at, what's this other one? 120. And then we can put those into radians as well. So a little bit of a look ahead. Not something to fret about for Monday's quiz, right? But it goes along with what we've talked about with reference angles. It goes along with what we've talked about with quadrants. It goes along with unit circle values, all that stuff. So it does play in. It helps us get better at all of this stuff as we start to think about these, okay? So, I was going to have you do your calculator. So try this on your calculator. So do negative square root of 2 divided by 2. Get that decimal, hit equals and everything. And then do second cosine. And if you're in degree mode, I assume, what do you get? You get 135. So you'll always get one of the angles. So in that case, you got the one in quadrant 2, and then you would have to know, okay, where else is cosine negative, cosine to the x? That would be down in quadrant 3. X would be negative in these two quadrants. So then you would use reference angles and triangles possibly to find that other. So that's the value of reference angles, even when you have the calculator. And then here, what you'd want to do, what I would want to do with cosecant is I'd first want to switch it to sine. I'd first want to switch it to sine and get it simplified down. Now I can type in square root of 3 over 2, it equals, and then do second sine, and you get 60. And then you find the other. Okay. All right. Go ahead and try these right now. This is the question Jack asked about. Okay. This is related to the question that Jack asked about. So this is definitely something on the quiz where I just give you trig functions of special angles and want the exact values, which is code for no calculator, right? It's code for no calculator. I want those answers in square roots and fractions, not decimals, okay? So when you hear exact values, so try those real quick. Okay? Now I did those real quick, so I might have messed up. I might have made a mistake. 3 by 4s you can actually draw a triangle for, right? What quadrant? 3 by 4s? 2, right? Quadrant 2. But it's 45, 45, so the y and the x are going to be the same. Tangents y over x. So they're the same, except one's positive, one's negative. Y is positive, but the x is negative, so that's why it's negative. Right? Tangent is y over x, so pi halves, 90 degrees, be 1 divided by 0, which is under 5. Tangent of pi, however, is 0 divided by negative 1, so that's 0. Okay, sine of 90 is just the y, so that's 1. Cosecant's 1 over the sine of 270. The sine of 270 is the y, so that's -1. So it's 1 over -1, which is -1. And then cosecant of 0, 1 over sine of 0. Sine of 0 is the y, 0. 1 divided by 0, of course, is undefined. Okay? All right. Let's do those. Okay? Again, exact value. Who's got 360? Who's got 360? All right. Can we look at these? All right. Now, I went ahead, again, possibly for some of you, if you're getting to the point where you can look at them and write them down, that's awesome. Great. Okay? However, I still may ask for you to draw a reference angle or a reference triangle on a quiz question for this. I want you to be able to do all these different ways of looking at them. But if we get into problems later on, or you get into calculus and you can look at sine of pi force, you just write down root 2 over 2, great. That's awesome. That's what we want to get to. Okay? But if I was asking you to draw a reference triangle or to draw the unit axis, that's what I'd want to see. Question, did I screw something up?
On number 3, shouldn't the tan be positive?
Oh, yeah, look what see what I did right here? Yes, I messed that up, didn't I? So I messed up number 4 too, which I based on number 3. Okay, good get. Right, how are you guys supposed to know this if you use it? Right, I forgot negative right there. Yeah, clearly when you go this way, that is a negative x, and when you go down, that is a negative y. Right, those should both be negative, and so that should be positive for sure. Okay, and then this one I just did, hey, cotangent's the reciprocal of tangent, so I just flipped it. I just took this answer and flipped it, and that's where I got that, so I didn't show any work. Okay, 2 pi thirds would be over here, that would be a 60-degree reference, right? 2 pi thirds would be a pi thirds, should have put pi thirds probably in there, but 60 is fine, I can do that because I'm not giving an angle answer. And so cosine is the x, so that's negative 1/2. Okay, secant's 1 over cosine pi halves. Cosine pi halves, here's pi halves. Cosine is the x. That is 0. 1 divided by 0 is undefined. Cosine 270, cosine is the x. The x is 0. Okay, so we're doing triangles or we're doing the unit circle for those other ones. Okay, so I may ask on the quiz to draw, if I give you one of these, to draw the reference triangle. So I want you to be able to do that, right? The reference triangle would be the one in the quadrant with its reference angle in there. Okay, so speaking of reference angles, here's what I want you to do. I want you to get up and find your partner. So if you have 30 degrees, change that to radians. If you have pi 6, change that to degrees and call out and find your partner. And then get with them here for the last 5 minutes.
Right up.
180.
60. Without any words.
All right, one of the partners come up here and grab a set of cards. They're labeled A through something, H or something like that. Okay, find the reference angle on a piece of paper. It'd be best if you both do it. Okay, one more group. Is there a group without one? Did somebody not find their partner yet? Just take one set. Yep, just take one set. Go and start with A. Well, it doesn't matter, but when you write them down, so on a piece of paper, let's write A through H, and let's draw a picture of the angle that you're given. Let's draw a picture of the angle. Some of them, the picture's already drawn. Okay, so that's nice. And then find the reference angle. That's all you have to do. Okay, you got about 3 minutes till lunch to get it done. No, we can come back after lunch. That's fine.
Are we supposed to do it for each card?
For each card, right? For each card. So you'll have A.
Yeah, find A.
So we're A through H.
So what does this have to do with this?
That's how you got your partner. That's just how you got your partner. That's all that is. I'll pick those back up. Huh? What's that? Don't draw on the cards. No, don't draw on the cards. Draw on a separate piece of paper. Draw it on a separate piece of paper. And you only need one piece of paper for your group, that's fine. We'll continue this where you're going to do it on your, where you'll do your own.
Just draw the reference angle.
Draw where it's at. So if you have 320, right? So draw 320 around into the fourth quadrant, and then give what your answer then is the reference angle. Your angle is the reference angle, which should be an angle between 0 and 90. Right now, if it's radian, give your answer in radian. If it's degree, give your answer in degree.
Pi 6 or 30. 30 or pi 6.
I love first and then Korean. I love how they're trying to.
Just because if you know how to do one, you know how to do
Yeah, they're basically the same problem. So, okay, so M5 and M7 wouldn't be bad to do for Monday. Those are kinda like what we're gonna be doing.
Are they all still do Friday?
Is that what Ally put in her planner?
That's what I put in my planner.
Yeah, so everybody said it, so. Yeah, that's a plan, we'll see how next week goes,
The
but.
10 through 12, add those on to our do items.
Yeah, all of those add on to all these item sales add on to this group, but the only ones I'd really say would be good to do by Monday would be 5 and 7. And we'll check over that worksheet before we do the quiz on Monday, so.
Mine isn't,
Yeah.
mine isn't a grade, so that's the only reason why I don't know. That's the grade, so I've been like that.
Oh, that didn't sound good. I don't know what to do something next.
So did everybody get a worksheet? 1, 6, 1, 7?